Dear friends, welcome back to my channel. Today we will have a relative equilibrium of liquids, which means translation and rotation of fluid masses. So as a general class of problems involving fluid motion in which there are no shearing stress occur just when a fluid mass undergoes as a rigid body, which is just in motion. So for example, if a container of fluid accelerates along a straight path, the fluid will move as a rigid mass with each particle having the same acceleration. So I think under this session we will have three types of liquids in which the container is just fixed with a boundary. The first one is liquid container subjected to horizontal acceleration, and also liquid container subjected to vertical acceleration, which is very important, especially in cranes and other motions, and liquid container with fixed rotation, just rigid body rotation. So let us see some examples on this one. Then we will have clear principle of this approach. So I think next example is liquid containers subjected to constant horizontal acceleration. So a tank 6 meter long, 2.5 meter wide and 2.2 meter deep is completely filled with oil if the container or the tank is accelerated in the direction of its length, which is this 6 meter length, at a rate of 1.5 meter per second square. How much liters of oil is spilled? So the tank is completely filled at 2 meters. So the volume of oil that will be spilled out will be calculated. So I think you will have drop in elevation. Just this is point B. So you have drop in elevation due to acceleration. You will have something overtopping. So you will calculate. So accordingly, just from the free body diagram of fluid element, we in three-dimensional axis, you can just compute del P with respect to X, and also del P with respect to Y, and del Z with respect to del P with respect to the Z. You can just derive the equation. Then the oil surface developed will be this equation, which is tan theta is equal to AX over G. AX over G. You don't have the y direction, so it is accelerating horizontally. So you have acceleration in x over g 1.5 over 9.81. So you have this value. So theta you can compute tan inverse of this value you can compute. So drop in the surface of the liquid. This is the actual after acceleration. This is the actual free surface of the liquid. So you can multiply, just 6 is this one, AB, tan theta is this drop in the surface of the liquid, BC over AB. Then you can find this value, drop in elevation, 0.9174. So the volume of oil spilled will be just the area of the cross section, which is just the spilled out, times the width. So you have width 2.5, then you can compute. So finally, volume will be 2.5 is the width, then triangular cross-sectional area ABC. This is ABC. Since it is triangle, you have half. Half times just the length, 6 times the height. Then you get this result, 6.88 meter cube. So you can convert into liters. So multiply by 1000, then 6880 liters of oil will be spilled out if it is completely filled. Okay, next, if the tank is filled by the oil of density 800 kilogram per meter cube to a depth of 1 meter, you see. So the depth is at 1 meter, but the total depth is 2 meters. So determine the maximum and the minimum pressure intensities at the bottom of the tank, S and N. S is this one, and N is this one at this point. And at this point, what will be? So total force acting at the front and back ends of the tank also we can compute, and the net force due to the water acting due to the fluid acting on each end of the tank will be completed. So I think this is oil. So we will use the oil density. So once you just draw the free body diagram, so you have 1 meter. This is 1 meter depth of oil. Then when it is accelerating with the same direction, this direction, then it will go to this direction. So new level will be H1 in the just in the back face. So front face is this one, in the direction of acceleration. So you have here M. So you can have H1 and H2. So just you can draw the free body diagram. So original free surface of the liquid is this one at 1 meter, but when it is accelerating, it will go just at the back face will be somewhat higher than the previous one. But at the front face, it will lower due to acceleration of the liquid. So you have just free body diagram. So this is back face F1, H1, then front face H2, you have force. So let us go to this calculation. So with AX constant, AY, AZ equal to 0. Clear? Because acceleration is horizontal. So you have dimension, this given, which is length, depth, and width already given. We are given these dimensions. These dimensions are given already. So you have length, depth, and width of the tank. So tan theta is ax over ay plus g. So since ay is 0, you can have 1.5 over 9.81. As previous, we already computed here. So theta tan inverse of this one, tan inverse of this ratio, then you have 8.69 degree. So H1 you can calculate now. H1 is this one. So H1 is H, this is original H plus L over 2, which is at the center here. This is from here up to here, L over 2, midpoint, L over 2 tan theta. You have to add. So tan theta is just here, some value divided by this one, then you add from H. Then you get H1, this is the H1 value. H2 is, since it is dropped in elevation, you have to subtract from original H. Original H is from here up to here, which is 1 meter. So H minus L over 2 tan theta will be this value. So 0.541 will be the second depth, which is H2, H2 front face. So maximum pressure, which will be just the larger height. So rho W, just rho W, G, H1, which is this value, 11,442.384 Newton per meter square. Okay, then the minimum pressure will be just density of oil, G, H2. So H2 is just the front face height, which is this one. Then you have 4,248 Newton per meter square. So forces acting on each end of the tank will be just, you will use force equation. So force at the back, which is at this point, you have F1. This is triangular distribution. You have the just unit weight of oil times H1, this dimension, and this is BE. The same is true for this one, B. So once you have this, then you can have just force equation. So area, which is this is the triangular area times the length, will give you just the force. So just half of density of oil times B times H1 square. So just density of just this is density just row of oil. This is H1. So if you have H1 square times B, then you will multiply. So you have 1 over 2, 800 times 9.81 rho G. Unit weight means rho G. Then you have this dimension, then 20,882.36 Newton. So force at the front face, which is this one, this is just the front face, which is F2. Then force at the front face, which is F2, H2. You have H2 height from here up to here. Then what is the force? So half of this one, half of rho G, which is unit weight, times you have B dimension, which is 2.5 times H square. So you get this result. So the net force is given by F1 minus F2, which is this one. You subtract, then you get this result. So I think this is all about liquid container subject to constant horizontal acceleration. So we will continue liquid container subject to vertical acceleration like cranes, etc. Just it is applicable. So thank you very much.